Hey everyone, we are Team 7, and this is our final project, the Python library coding agent. So, in the home page of the application, we have two buttons, one to log in and one to register. Once the user opens the register page, he can register a new uh, user into using the username, adding a email ID, and adding a password. So once you click on register, the user is registered onto the system and you're redirected to the login page. So now using the new credentials, you can log in. So in the home page, you have on the sidebar, you have five options. One is a drop down to choose the library that you want. And we have three features, which are how to guide, error handling, and app builder. And here on the main page, you can view information about the how to guide, how to use it, error handling, how to troubleshoot issues, and the app builder, and like how we can generate custom applications using the app builder. So, and you can also commit the code that is generated. So, in order to first commit, we have to set up our GitHub permissions. In that, so we access the GitHub commit page. In that, you have to enter your GitHub username. And then here you have to follow the steps to generate a personal access token. I have generated a personal access token. Uh, we'll use this to push the code that is generated into our repository. So once you click on the update GitHub credentials, the credentials get updated. And now the application has permissions to push code to the GitHub. So we have two options, one to build a code generation assistant or a PDF RAG agent, or you can input any custom prompt that you want. So let's test out building a PDF RAG agent. And we click on build application. And now the agent goes through a series of steps. So the first is it uh, it itself analyzes the prompt and comes up with a series of steps that it needs to follow in order to build this application. And then for each step, it goes to the LangGraph documentation, references the code, references the concepts, and then tries to generate code based on that. So for each step here on the UI, you can see the documentations that it's referencing. And these are all specific to a LangGraph. And once all the documentations are referenced, then it starts building the application. So here we're using Claude to build the application. And for each of these documents that it's referencing, it's using Claude and generating both the front end as well as the back end code. So once the code has been generated, now it's begin to evaluate the code performance. So we have a feedback agent where the code is being evaluated for syntax errors and for the checking if the LangGraph concepts have been followed. And then once the evaluation is done, it goes back to the code generation in order to implement these feedback to modify any syntax errors that is present in the application. And once the whole code is generated, then you'll be able to see the front end and back end code here. So the front end, the agent has built it using Streamlit, and the back end it has built using Chroma, LangGraph, and LangChain. And once the whole application is ready, you have a button to launch the application. So once you click on launch application, it starts the application and the application is running. So the way it has launched it is through the pip install of the requirements.txt. So the agent also gives you a requirements.txt that the application has to be run on. So first we have done a pip install of that. And then we have also included a README for the whole application here. And then once it does a pip install, it does a command of streamlit run frontend.py, and then the whole application is deployed. So the backend is generated using this code of documentation. So for each of these, you can see it's referenced agentic RAG. Since we asked it to build RAG agents, it is checked for documentations based on RAG. So any of these code that is there, it is referenced this to uh, check the working of the application backend. Now you can click on the open app and we can view the application. So Dipen will take over from here.
Once we click on the open application, it will navigate to the application which we build based on the front end and the back end provided by the code agent. And over here, the user can either enter the OpenAI key and can upload the PDF and chat with this RAG agent. Now we'll proceed to how we can commit this particular code onto the GitHub. So we do have an option for entering the repository URL and the commit that we can put commit message that we are supposed to put it into the repo. So right now we'll just copy the repo URL, we'll enter it onto the repository URL GitHub, and we'll enter the commit message as well, and we'll click on commit and push. Once we click on commit and push, you can see the GitHub credential found, and the front end, back end, and the requirement.txt and readme.md will get updated into the URL which we have generated. So you can see right now it got pushed. We can see there is backend.py, frontend.py, and this is the README which was generated by the code generation. Now we'll move to the error handling part. In the error handling part, the user has the option to enter the task. So a user can enter the query onto the task field, and there is also an option for entering the code. So if user encounter any errors in the code, particularly, user can just copy paste that particular code into the code text area, and the error message which is like generated for this particular code. So we'll just paste the error message onto the error message text area, and a user can analyze the error. Now, based on the error message which we enter, it will generate a relevant document. Over here, we are using the Google search, using the SERP API, and the error handling agent will generate the relevant document based on the Google search, and it will retrieve the documentation based on the web search which is there, and it will generate like the message uh, based on why the error is coming. So you can see there is why the root cause for the error, the explanation, and it will give the suggestion fixing for the code as well. So we do have the original code, and in that we can also see the corrected code which was given by the agent and the explanation to what. So you can see there is a workflow state graph, and we particularly remove that graph state, and the corrected code got the error fixed in this. Now, so user can also give the feedback whether like the particular response which is generated, was it useful or not, by just giving yes or no, and this response will help in calculating the accuracy as well. Now we'll move to how to guide.
Yeah, so with how to guide, yeah, the user can specifically mention what library they're trying to use, and I mean, based on the selected library, they can give a prompt of what they want to do. So here we have like given two test cases. One is like to generate a code generation assistant, and a PDF based RAG agent. So if the user wants to know how this has to be done in a step-by-step basis, they can just give a prompt to our application, and our application will generate a step-by-step process of how that particular application can be generated. So this will be kind of a step-by-step process. So basically, whatever query it goes into our agent actually generates a set of research steps. So and for those research step, it actually retrieves the relevant documents from our Pinecone RAG, And based on that, it will also list here the steps which it's gonna take and the documents it's gonna refer. So if you click the source link, it will actually take you to that particular documentation page, which is it's trying to refer to generate this particular code. Um, yeah, so these are the serious step of actions it's taking. Once it's able to I mean, come to the final node, it will give the answer as well. So it basically gives like a step-by-step basis, like what code it needs to be generated and how it's kind of generating. It will give you a step-by-step basis of with the explanation of what each particular code chunk means. With this, the user can actually make some changes and construct the graph based on their own use case. So here we have tried to base a RAG-based agent, so it has given the retrieve requirements, generate code, and I mean code-based generator code. So it's actually has given the code to generate the code. And yeah, this is on high level how the how to guide works. Maybe now we can go to the Airflow part. So for the Airflow part, yeah, so it will be uh, yeah, it's admin. So basically, we have two racks. One is to process the documentation extraction. So once the user gives a URL of what documentation they want to scrape, they should also give the base URL as well. So basically what it does is this load recursive URL task, it will scrape the documentation, and process and store task will process process that particular scraped web page in a particular format, because we wanted to store the code in a particular place, and we have to store the other part of textual information in the pinecone index, so that when a user tries to query on a particular, I mean, wants a particular thing to be done, the relevant documents can be fetched. So we store that in a pinecone index. And yeah, that's being stored in the pinecone index. This is for the documentation extraction rack. And we have another rack to parse the elements which is in the GitHub repo. Let's say we're going to parse a Langchain repo. I mean, Langchain GitHub repo. First, the repo will be cloned to the particular, I mean, whatever directory we give. And it will list what are the files present in it, the py files, ipynb files, and md files. And each py files, ipynb files, md files will be processed in a particular format, and yeah, they will be loaded into Snowflake. So this particular will be loaded into Snowflake in a structured format. These information is being used by our research graph to retrieve the relevant documents. So basically, based on our I mean, whatever query we give, the relevant information will be fetched from our RAG agent, and it will check like if there is any functions, classes included in that particular documents which is retrieved, and if there is any specific functions and classes, it will go to our SQL database and fetch that particular functions alone, and that will be sent to the LLM to generate the code or whatever expected output. Yeah, this is high level overview on our application on how things work. Thank you.